Now let us see this next illustration, which is quite an interesting one. We have to find out from a given set of real life situations whether the given mathematical relation that we can obtain from a given circumstance is an AP or not. So the first circumstance or the first situation is that there is an air cylinder present, and you put a vacuum pump to take out the air from it. And what do? Whenever you use the vacuum pump, it removes 1/4 of the air that remains in the cylinder. And then we have to find out if the list of numbers or the sequence of numbers that we obtain would be an AP or not. So let's see. When the cylinder is full of air, let the volume of air be V in the cylinder. So this is going to be the first term. V is the volume of air in the cylinder. We have to find out the amount of air present in the cylinder. So the amount of air present in the cylinder initially is V. When we use the vacuum pump, what will it do? It will take out 1/4 of the air that is there in the cylinder. 1/4 of V would be V by 4. So the vacuum will take out V by 4 of the air from the initial amount of air that's present. So we will get 3V by 4. So initially the air in the cylinder was, the amount of air present in the cylinder was V. After you use the pump for the first time, the remaining air would be 3V by 4. Now what do? We again take this and we take out 1/4 of the air. So this is the air that is there. 1/4 of 3V by 4 would be how much? 1/4 of, so it will be 3V by 16. So what will be the amount of air remaining in the cylinder? The amount of remaining air in the cylinder would be 3V by 4 minus 3V by 16, which will be equal to, you get 12V minus 3V, so you get 9V by 16. Is it correct? You get 16, 12 minus 3, so yeah, so it's 9V by 16. So the amount of air will be 9V by 16. Now we have this much of air remaining in the cylinder. You again put the pump, which will take out 1/4 of the air. 1/4 of this would be how much? It will be 9V by 64. So how much air would remain in the cylinder? It will be 9V by 16 minus 9V by 64. If you take out the LCM, it will be 64. 36V minus 9V, that will be 27V by 64. So how much air will remain? 27V by 64. Now we have got a list of 4 numbers. We can now check whether this given sequence of numbers is an AP or not. So we take the difference, the common difference of 3V by 4 and V would be how much? 3V by 4 minus V would be minus V by 4. Let's see if the difference remains the same throughout. So we have 9V by 16 minus 3V by 4. How much do we get? 16. So it's 9V minus 12V. We get minus 3V by 16. Does the difference remain the same? It does not remain the same. Hence, the given list of numbers that represents the amount of air remaining in the cylinder would be V, 3V by 4, 9V by 16, 27V by 64 and so on, but this does not represent an AP because the common difference is not the same. Now let's see the second question. What does the second question say? The second question says that the cost of digging a wall for the first meter is rupees 150 and rises by rupees 20 for each succeeding meter. So the cost, we have to find the list of numbers representing the cost of digging a wall. So the cost of digging a wall that's 1 meter in height is 150. What will be the cost of digging a wall 2 meters in height? It will be 150 because for the first meter it is always 150 and then it rises by 20 for each succeeding meter. So it will be 170. What if the wall is 3 meters? The first meter will be 150 and for each of the remaining we will be obtaining this. Similarly, if we go on increasing the height of the wall, we are going to obtain a list that is similar to this. So what exactly do we obtain? We obtain 150, 170, 190, 210 and so on. So we observe here that the common difference always remains as 20. You see that the common difference of any two numbers in this list always remains as 20, which is a fixed number, and hence this particular situation is going to represent an arithmetic progression, whereas the earlier one did not, because the common difference did not turn out to be a constant number. So far we have seen how we identify an AP, how we find out the common difference and the first term from a given list of numbers if it represents an AP. And if we are given the first term and the common difference of an AP, we can also easily form the AP, corresponding AP. And in this particular example, we encountered two situations which have been taken out from practical examples, wherein we have to identify whether a particular characteristic, a particular list of numbers represents an AP or not. I hope you understood it. Now you are going to have your first proficiency test after this, and after that we are going to get into the second main topic for the arithmetic progression chapter.